Hello, just I have opened one PowerPoint. Is it visible? Hello.
Yes, it is visible.
Okay. So last day already we have discussed on hydroboration reaction as well as olefin metathesis reaction. Have you read from any book or from internet from any other source, or do you have any question about that? Don't have. So today we will start with the new reaction. That is new means actually already you have learned in 11 12. So that is the Wittig reaction. Okay. And about Wittig reaction, just I will say you George Wittig. He was also awarded Nobel from the same platform. That is the with A.C. Brown. Both were shared the Nobel Prize of 1979. And George Wittig, I am audible. Are you hear me?
Yes, sir.
Oh, okay. Okay. So, Wittig reaction, that is also another milestone in the development of organic chemistry. And what is its important? Just I will say you first. Actually, always remember the reaction which we are discussing here. Most of the reactions are directly or indirectly related with the Nobel laureates. Actually, here the our motive to say the importance of the reaction and why this reaction, what type of works they have done, and why they were awarded Nobel. And all these things, I think, all that will encourage you in future to involve yourself in basic science, actually fundamentals work. And always remember, if you ask me, sir, we are going to be engineer, but why we will pay our attention in Nobel? Always remember, if you have to do for the human beings, then ultimately you have to involve yourself in basic research. And when you will do the basic research, you will discover a new things which is not known to us, and which change the actually the lifestyle of the peoples. Then Nobel committee will recommend for Nobel. Okay, so we expect in future that from this young generation of our country that they awarded Nobel. So this is also another aspects. And now I will say you about the Wittig reaction. Actually, George Wittig, he discovered this reaction. Actually, what is the reaction? Reaction is very simple. It is not too tough. It is very simple one. That is a carbonyl compound that will be transformed to corresponding alkene. That means CO group will be transformed to C double bond CHR. CHR. So what is the reaction? You see here, this is the carbonyl compound, that is the benzaldehyde. So carbonyl compound when react with the ylide. Actually, this is the ylide, triphenyl phosphine, methylene triphenyl phosphine. This is the ylide. And ylide, how it is synthesized, that is also explained here. Actually, when triphenyl phosphine react with methyl iodide, then the iodide group is substituted by the triphenyl phosphine, and it forms triphenyl phosphonium methyl iodide salt. It forms triphenyl phosphonium methyl iodide salt. Now you see here, this methyl group attached with the phosphorus, that is the plus charge, as well as it also attached with three phenyls group and phenyls group that have the minus side effect. So positive charge at this at the phosphorus, actually that makes the methyl hydrogens are quite a little bit acidic in nature. And this acidity actually utilized by George Wittig to synthesize the ylide, and at that time he also aware about the organometallic compounds. Already I told you. Yes, one story I will say today, if you are interested, about the H.C. Brown. Actually, what was his motivation, and how he become encouraged and his lifestyle. Okay, his life history. So alkyl lithium, N-butyl lithium, that act as a strong base, act as a strong base, and this base actually that abstract the proton here, and it forms the carbon ion, and this carbon ion is stabilized to triphenyl phosphine, and its form corresponding ylide. This is the ylide, as it is the phosphorus is there, so it is the phosphoylide. So this is the synthesis of the ylide. This is the synthesis of the ylide. I think it is clear to all of you. And this ylide, when react with the carbonyl compound, just it is the addition reaction to the carbonyl carbon. Due to electromagnetic effect, this carbon oxygen double bond. Just one phone I have to receive. Hello, hello. Okay, so this is the addition, just plain simple addition reaction, and it gives corresponding carbon, makes a new bond, that is the methylene group of the ylide with the carbonyl carbon. And now this one you see, actually it through carbon carbon single bond rotation, the phosphonium triphenyl phosphonium as well as the alkoxy group that come in the same plane, and it forms a sigma bond, and that forms corresponding four member butane. This is known as butane, and this butane, four member butane, it is four member and heterocyclic, so it is very unstable. It is very unstable, and it's rearranged to decompose to form corresponding alkene. You see here, this is the carbon carbon double bond, that new carbon carbon double bond is formed instead of the carbonyl group of the alkene. And this is the milestone in the development of chemistry. Why it is actually, by means of this Wittig reaction we can synthesize different types of alkene, and that alkene can be utilized for making the smart materials, particularly the polymers, the different biomolecules, drug molecules, and so many different insecticides, pesticides, and so many compounds that we can synthesize from here. And this is the byproduct, that is the triphenyl phosphine oxide, triphenyl phosphine oxide. So this is very simple reaction, and this mechanism also proposed by George Wittig. So as a one-man reaction he proposed, and he was awarded Nobel. But also it became late to announce by the Nobel Committee, that have another actually what I say, that is the reason. I will not mention here that one. But this reaction that is mostly related with the stereochemistry. Actually, this is the stereo-regulated nucleophilic reaction of different steps of the Wittig reaction. You see here. This is the substituted ylide. This is the substituted ylide. Actually, this is the charge separated. That is the phosphorus become plus, and carbon that become the carbon ion. So this charge separated carbon ion that attack at this carbonyl carbon, as I explained. And if it is attacked to this sp2 carbon, actually this is the carbonyl carbon, and this is the sp2 hybridized. And sp2 hybridized means actually it is planar, either from the front side or back side. If it is attacked from the front side or back side, so their substituent are oriented in such a way that should feel the minimum repulsion. So have two possibilities of their actually attack, and this is the staggered conformation of their intermediates. And you see here the triphenyl phosphonium as the alkoxy group in opposite side, but here it is quite close, quite close, means that have a more easier to form four member butane, to form the four member butane. And this four member butane, when it is formed, and easily it can decompose due to rearrangement of the sigma bond followed by formation of the pi bond, and we obtain the alkene. So in this case we obtain the cis alkene. Cis, it is the cis means actually that is the Jusamen. Anticakin and Jusamen cis and trans term are not always used for geometrical isomers. E and Z. E means the anticakin, Z means the Jusamen. Jusamen means the same side, and anticakin means in opposite side. So two alkenes have a possibility of form, but here it forms the cis one. So if it is actually if it is your desirable compound to obtain the cis one, so you have to follow this reaction methodology, and you will get corresponding cis alkene. And this one also nicely presented in the eclipsed and staggered conformation. This is the Newman Sohers, actually Newman and Sohers, I think Newman and Sohers projection. So this is the Sohers projection also shown here, and this is also there different possibilities of formation of the four member butane, and this butane actually which one feels less repulsion, their potential will be the less, and that will decompose and gives corresponding alkene. So you see here depending on the substituent, depending on your structure of the ylide, as well as your actually structural ylide is very important, as well as your structure of your carbonyl compound. So depending on their actually structures, actually we will obtain either cis or trans alkene, either cis and trans alkene. Now you see here, this is one very simple example. Hello, any
Sir, can
problem?
you, yes, sir. Can you repeat the stereoisomerism? Sir, I cannot understand the second step as why it comes.
Yes. Why not? Yes. You see here, this is the carbonyl. Okay, actually, ylide that generally stabilize through phosphorus carbon double bond. But ultimately, when it react, the charge become pi electrons that separated, phosphorus become the positive and the carbon become negative. So these carbanion that have a tendency to attack at this carbonyl carbon, and this carbonyl carbon is sp2 hybridized, that is the planar. So it might attack from the front side or back side. If it is the planar, so this planar system either that will attack from either this side or from that side. But these two attacking actually side, actually the which one will be the favorable, that depends on the steric repulsion of their substitution of the substituent of the your ylide as well as your substrate. So they have a possibility of the two, and you see here this is the one possibility, this is the another possibility. These are their corresponding Newman projection, that also the same. These are the almost exactly the same, but they are actually mode of their presentation are quite different. And these two intermediates actually that rotate through carbon-carbon sigma bond. This is the new carbon-carbon sigma bond that formed, and due to rotation, actually it comes close of that phosphonium as well as the alkoxy group in the same plane, and that form the four-membered ring, and it gives corresponding alkene. So is it clear what I told you?
Yes, sir. But
Hello.
why? Yes, sir. But why it turns in the most unstable form?
Yes, actually always remember steric repulsion, if it is the field, so that will not favorable attack. So which one is the less steric repulsion, that one again that will try to rotate either from the clockwise or anti-clockwise. If it is the rotate from the clockwise and feel more repulsion, that will not favorable, so then the opposite will be the favorable. So depending on the steric factor, actually that actually rotate and forms the four member butane, and that four member butane their arrangement, and that remain in the scene away, that eliminates in the scene away, and it gives corresponding alkene. So depending on this actually rotation as well as the attacking group, actually that gives corresponding that product. Do you follow me?
Yes, sir.
No, it is not clear. Yes means yes. If you have understand, that's okay. Otherwise, I can repeat, no problem. Okay.
Okay,
So,
sir.
hello, hello.
हाँ सर बुझे जी सर.
Okay, very good. So, this is the very simple example, that is the cyclohexanol. This is the carbonyl compound. এই ইয়ে একটু জল আছে তো একটু দাও তো। carbonyl compound, and this is the ylide. This is the methylene triphenyl phosphine. Okay, so this is the triphenyl phosphate methylenide ylide, and this ylide attack in the carbonyl carbon, and it goes through formation of the butane, 4-member butane, and followed by elimination process, and it gives corresponding methylene cyclohexene, 1-methylene cyclohexene. And if you follow the hydrolysis reaction, so same what I have discussed in the last day, that is the boron hydride monomers in tetrahydrofuran and hydrogen peroxide and sodium hydroxide, that is the hydrolyzing agent. It gives corresponding cyclohexyl methanol, and this cyclohexyl methanol, if you oxidize to selenium dioxide, then it will form corresponding aldehyde, and aldehyde group that can attach to another moiety as you like, so you can couple one ring compound to another ring compound. So this is just a milestone in the development of the other cyclic products. You can couple for making different biomolecules which are important for our daily life. So this is just an example. Now I will say you about the product formation, whether it will give the alkene, that is the ultimate product, that will be the E isomer or Z isomer. E means the when to bulky group with respect to the double bond in the opposite side, then it is the E means anticoagulin. When the bulky group are in the same side, then it is the juiceomer or Z. You see here, this is the product. Actually, this product we obtain from the benzaldehyde and also this ylide, and this ylide actually unstabilized. Unstabilized means actually it can it more easier to exist as a phosphorus carbon double bond than charge separated unit, that is the phosphorus plus and carbon minus. That is not so favorable because this methyl group that donate electrons to the carbon ion. Okay, so it is unstabilized. These ylides are also two types, stabilized ylides and non-unstabilized ylide. Unstabilized ylide actually where it favor mostly to become phosphorus carbon double bond, but at the time of reaction it actually exists, but it is not so stable. Okay, so depending on their stability as well as their structure, actually it react with the corresponding carbonyl compound, and ultimately after decomposition of the butane, that gives corresponding alkene. This is the alkene. You see here the phenyl group and methyl group both are in the same site, that is known as 87% juiceomer and 13% is your anticoagulin E isomer.
Sir,
Sir, how can I understand the phenyl?
concentration of Z is more in this. Sir, that
Yes, actually that you have to identify, or quantitatively you have to measure which one by spectroscopic evidence. It is not so easy. What I am explaining here just the reaction, but when you have to conduct the reaction in laboratory, then it will take more time, and so many different techniques are there to understand which one is the cis and trans as well as the percentage. Okay, percentage. Actually, the cis and trans, their solubility in different solvents are different, and so that have to separate by means of solvent extraction process. And after separating the solvent extraction process, which one, how much you got, from there you can determine your percentage. Is it clear?
But
Hello.
how can I determine
yes,
in the
sir. So,
examination
matlab,
hall?
there is no
How
method.
you determine? Hello.
So on paper,
You clearly ask me what you want to say. How you determine which one, percentage or structure?
ইয়ে স্যার পার্সেন্টেজ স্যার যখন আমাকে স্যার দেবে আমি কি করবো স্যার উল্টোটা উল্টো করে দিতে পারি মেকানিজম দিয়ে।
No, when you have to separate the both isomer, geometric, actually this is the geometrical isomer E and Z by chromatographic method, then you will get one product certain amount and also the another product certain amount. Then when you will compare their amount of product, then you will get the ratio from there. Okay, so you have to separate the product and you have to get the weight. Otherwise, how it is possible? It is not so easy. What I told you. Okay, is it clear? You have to separate by column chromatography, by HPLC. So many different techniques are there. Okay, so different techniques are there. Based on that, we have to separate. Now you see here the same compound, that is the benzaldehyde, but your ylide that is stabilized. Stabilized means phosphorus carbon double bond is there, but that is attached with the ester group. Ester group means this double bond, that means the phosphorus plus and your what I say, that is the carbanium that become negative, that will actually stabilize, by means of your ester group through conjugation, and it also give the same type of actually same type of reaction, and it gives only the E isomer, E means opposite, both phenyl group as well as your substituted ester group, that in opposite with respect to the double bond. Is it clear?
Sir,
But
sir, कौन
cannot understand the
You see
meaning.
the just one by one
Meaning.
you ask.
Yes.
Hello.
Sir, cannot understand the meaning. The first sentence which you have written, the ratio of Z isomer decreases as electron withdrawing group is added.
Yes,
Sir, that sentence is there,
the
but
ratio, the ratio of the Z isomer decreases as electron withdrawing group are added. You see here, here what it was, Z isomer 87%, E isomer was 13. Here it is the methyl group in the ylide, that is the electron donating group. Okay, electron donating group. It was electron donating group and it is unstabilized ylide. It is unstabilized ylide. But here it is stabilized ylide. Stabilized ylide. So Z isomer, percentage of Z isomer that decreases as the electron withdrawing group. Actually, ester group is the electron withdrawing group. Okay, are added to the ylide. So these species are called stabilized ylide as they are less basic and less reactive, but it gives corresponding exclusively the E geometrical isomer. Is it clear or not? I have to
yes,
repeat
sir.
it.
Sir, statement I've understood, but why it happens like this?
So that you have to follow the mechanism totally. Okay, so that is actually it goes through different approach, of your carbon ion to the carbonyl carbon, and when it approach from the front side or rear side, actually that governed by the substituent as well as their reactivity. Okay, actually in this case you see here, if it is stabilized, then reactivity will be comparatively less. Yes, that is written here. Yes, stabilized ylide as they are less basic and less reactive. Okay, so as it is the less reactive, so that is more selective. I think all you know about chlorine and bromine, they gives almost similar type of reaction, but chlorine is more reactive and less selective. Am I right? Whereas bromine is less reactive, more selective.
Yes, sir.
Is it clear? You know the statement?
Yes, sir. We know the statement.
Okay, very good. So the same thing. If it is the less reactive, so that will be more selective. So selectively that will approach to the carbonyl carbon, whether it will form the same with the minimum potential energy of their repulsion of the bulky group or more. And their decomposition that also goes through reversible pathway, reversible and irreversible. Actually, that mechanism we discussed in master's student. Okay, so that is not included in your syllabus. It will take more time. So depending on the structure, actually their approach to the carbon ion to the carbonyl carbon, as well as their decomposition that will reversible or irreversible, and that their potential energy. So many factors are there. So depending on that, actually it gives almost exclusive or as a measure the E isomer, not a geometrical isomer. Is it clear?
Yes,
So
sir.
we have to remember these examples.
Yes, actually what I discussed, beyond that one I will not give you anymore. Okay.
Okay,
So
sir.
this is the statement that this is simple enough and probably enough for most purposes. Okay, means most purpose means chemistry actually follow the general statement but have some exceptional case, that is the chemistry. Okay, so whether it is actually exclusive E isomer or certain percent Z, that depends on the so many factors. Okay, so we do not have time here to get into the excellency. Actually, we say it is the immun modification reaction. Actually, Horner, Imon, and Woodwards. These are the actually research group. Woodwards is their professor of Horner and Imons, but Imons mostly work this one. So they modify the reaction to get a certain percentage of E or Z. Okay, they also actually modify their reaction that have in our higher in master students syllabus. Now just I will give you one example, that is the intermolecular Wittig reaction. What is intermolecular reaction? Intermolecular, so within the compound the carbonyl group as well as your alkyl halide is there. Alkyl halide in presence of triphenyl phosphine that forms corresponding ylide. So that ylide step I have not shown here. So this end that forms the ylide and carbonyl group within the compound is there, so that will give you the intramolecular Wittig reaction and we will obtain 1-methyl cyclohexene as a product. 1-methyl cyclohexene. So this is the example of intramolecular Wittig reaction, like intramolecular aldol condensation. I think all you have learned for your JEE main and advanced. Okay, so this is about the Wittig reaction. If you have interest, then you follow the Graham Solomon, Keruthars. No, sorry, Keruthars is the books for reagent, but actually Clayden actually that is a book where the master students follow. So you can follow this book for your better understanding, or better understanding means advanced topic if you like to understand about the Wittig reaction. So for your syllabus this is sufficient. Okay, actually our motive to encourage the student how a reaction, the fundamental reaction discovered as well as their mechanism, and without mechanism the reaction is invalid, and when both the reaction as well as the mechanism is proposed by George Wittig, he was awarded Nobel. He was awarded Nobel. Now I have given here a few problems, and that was solved also given here. So you try to understand without actually take the help of the solve part. When you will not able to actually solve, then you can take the help, and next day if you follow face any problem, you ask me, I will help you. Okay, so these are the different problems. Homework I have
Sir,
given.
have you uploaded the material?
Hello, yes, today I will, no doubt I will upload for both the section, F section and I section. Okay, no
So
doubt.
because the team is not created, I think yet for chemistry.
Okay,
Only
team.
in calendar we
No,
are
no,
getting.
actually in MS Team I will upload. Okay, today. I will upload in today at the end of the class. Okay. So these are the homework about the Wittig reaction, and now I will discuss on the immune modification reaction, Horner, Watts, and immune modification. And this modification actually important to separate the alkene. Actually, the alkene and triphenyl phosphine oxide both are soluble in the common solvent. So if they are soluble in the common solvent, ওই সুইচটা দাও তো, ওই লাল সুইচটা এসিতে দাও, এসিতে লাল সুইচটা দাও, প্রেস করো, পেয়েছো? বলছে না? ये देखिए ये मतलब रिमोटটা দাও কি হলো জ্বলছে না গরম করছে তুমি তাহলে একবার গ্রিনটাকে প্রেস করো গ্রিনটা হ্যাঁ হ্যাঁ ঠিক ঠিক হ্যাঁ ঠিক ঠিক আছে দেখে নাও আচ্ছা so immune modification actually that helps to separate your alkene which is your desirable product and undesirable product that is the triphenyl phosphine oxide so that separation is very important and that can be easily done by means of the immune modification so immune modification actually you see are instead of triphenyl phosphine he take the compound as a diethoxyphosphine phosphine oxide methylenide ester methylene ester okay so this is the substrate and this substrate when treated with the strong base that is the sodium hydride is a strong base so it abstract the carbanion and this carbanion naturally attack at the carbonyl carbon and followed by formation of the butane four member phosphobutane and that phosphobutane decompose and ultimately you will get corresponding alkene that have the R group that is the alkyl group and one ester group so this is the actually your desirable alkene and from this alkene actually if you hydrolyze you will get corresponding acid and acid if you reduce to aldehyde or reduce to alcohol as per your requirement and it easily that can be separate from the your product as well as your byproduct so immune modification is very important for this purpose so these are the different books that I have recommended here. Peter Sykes, it is very important book for mechanism and Graham Solomon, it is very common book for the undergraduate students. Actually, renowned book throughout the world. It is actually students follow to your teachers and students. Bolo.
Sir, can you just bring back to the previous page, sir? Once just. Thank you, sir.
Okay. Now, I will discuss now here the Robinson annulation process. Robinson annulation process. So, what is the importance? Why this Robinson annulation process among all the reactions? Why we have included? That I will first of all I will explain. Actually, in 1935, 32, 35 at that time, chemists feel the methodology for cyclization process because society demanded for different biomolecules particularly different steroid different prostaglandin different what I say different type of biomolecules okay but people thought only the cyclization is possible within the physiological system or within the plant actually the natural product which we obtain from the plant that most are cyclic product and also the different steroid that is the different hormones particularly for our growth for different actually for male and female that are actually all these are cyclic compounds and the demand are to synthesize different biomolecules particularly the steroid in laboratory in laboratory but cyclization process was not known to the chemist organic chemist so they were actually not able to do at that time but Robinson he able to do this cyclization process but have a interesting story behind his discovery and to award the Nobel. Actually, when Robinson was working under his professor, is doing his PhD work, his professor was interested about the Michael Edison, their carbon-carbon product formation, carbon-carbon products formation. So, what is the Michael Edison? That first of all, I will say that is the carbonyl compound having alpha hydrogen. you see here, this is the carbonyl compound, this is the carbonyl compound, and alpha hydrogen is there. And in presence of strong base, this alpha hydrogen can be abstracted and it can form the carbanion. And this carbanion that is prone to attack the alpha beta unsaturated carbonyl system. This is the alpha beta carbonyl system. This is the carbonyl group. This is the alpha carbon. This is the beta carbon. So this is this resonance star. Actually, it can gives another resonance structure that will be alkoxy, as well as here the carbocation that will generate, and the carbanion that attack as the beta carbon, and it forms corresponding new carbon-carbon bond. This new carbon-carbon bond it will be formed. So different chemists at that time was interested to follow the Michael Edison and to obtain different carbon-carbon product as per their requirements. So the professor under whom actually Robinson working, he told him to conduct a special reaction that I will show you. Here it is not there, but that one is the he actually he was first it tried to do this reaction with a substituent of the cyclohexanone in alpha position. So if it one methyl group is there in alpha position, so both alpha and alpha dash, the alpha hydrogens are there. So by means of base, both carbanion is possible. So which one will be the major or minor or like this? So that was his target. And his professor told to purchase one compound that will be 1-methyl cyclohexanone. This is the cyclohexanone, but his professor told him to purchase 1-methyl cyclohexanone as well as 1-phenyl alpha beta unsaturated carbonyl compound. But Robinson was not so attentive. Actually, he was very genius, but he was not attentive what his teacher told. Generally, as a PhD supervisor, don't talk, please. Don't talk. So, so this one is the actually plan to synthesize a different compounds, but Robinson he was actually not pay his attention what which compounds his teacher is recommending, but he give the order to purchase different compound. So what was the compound he give the order? That is the 1,3-dione 2-methyl 1,3-cyclohexadione. Give the order, as well as that is the beta phenyl alpha beta unsaturated system. So after doing the reaction, conducting the reaction, they purify the compound as well as the characterized by spectroscopic method. After 1 or 2 months, generally what we say, we call the students, what you have done last 2 months, you show me and explain. So when he saw the different reaction products as well as their spectroscopic data, so he was not satisfied. Actually, his professor was not satisfied, because what he expect and what his student is saying, they are have a hell and heaven difference. So he argued, I told you to purchase this one, why this one like this? So he threw the total report what his student Robinson show his professor, but he threw the total materials into the dustbin and also say some ugly words about his absent-minded. So many things happened. So after completing his PhD work, he joined in another university as a assistant professor, and he first conduct the reaction again, and that work is published in his reputed journal, and throughout the globe, the chemists were pleased what he has done. Actually, he has completed the desirable minds actually product, that is the cyclization process. He reported the cyclization process. So at the early age of 39, he was awarded Nobel in 1947. So you imagine the which materials is thrown by his professor into the dustbin that utilized by Robinson, and he was awarded Nobel. So when he was awarded Nobel at the actually Nobel ceremony platform, he actually dedicated his Nobel to his professor because he was his teacher. He was his teacher. Okay, so this is the history. And what is the reaction? Now just I will say you the very common reactions. Actually, you see here, this is the cyclohexanone. Actually, this is a problem. One thing, actually have a possibility to attack either this and this is the common, no problem. So the carbon ion that attack at this carbon means it forms such type of addition product. So this new carbon carbon bond that forms. Now you see here again, in presence of base, that will this methyl group, that is the active hydrogen is there. So this carbon ion will be generated, and that carbon ion again can attack at this carbonyl carbon, and it forms such type of cyclic compound. And this is the beta hydroxy ketone. This is the beta hydroxy ketone. So one alpha hydrogen is there. So it eliminates one molecule of water and it forms corresponding alpha beta unsaturated compound with cyclization process. So he has completed this reaction. He also proposed the reaction as well as report the reaction in journal, and all the throughout the globe people know his reaction, and that methodology is followed for other purposes, and he was awarded Nobel. So this is the history as well as the chemistry as well as the mechanism of Robinson annulation. So this is very simple one, but it was the fundamentals work at that time. Always remember at that time, you remember this one. Okay, so Michael Edison already told you, and not actually these are the same things. It is not required to mention. All these things are the common thing. Now I will say you a few words about the organometallic compounds. Organometallic compounds. Just I will say the history or the motivation about the discovery of the hydroboration reaction first, and there I will say you the about the organometallic compound, why it is so important. Actually, organometallic compound, that is the compound which in which the carbon metal that forms the covalent bond but ionic in nature, and this organometallic compound that change the miracle change in the actually chemistry, actually different products with a high yield, with easily that can be conduct, easily can be purified. So different compounds that can be synthesized with the help of organometallic compounds. And organometallic compounds, particularly the carbon metal bonds. So different organometallic compounds have been discovered initially. You see this is the ferrocene, actually cyclopentadiene, 2 units, 2 equivalent that actually sandwich the iron. So it is the known as ferrocene. Actually this is the carbon carbon double bond, 2 double bonds are there, and that through this 5 carbon actually partial bonds actually formed with the iron. In the same way this one, this is the cobalt ferrocene, cobaltocene. This is the also the organometallic compound, and this one is the this is the actually Wilkinson catalyst. This is the Wilkinson catalyst, actually Wilkinson catalyst that is used for polymerization reaction. And this is the this is the hydrogenation reaction, and this is the Gysel salt. Gysel means actually this is the actually Walker. This is also the polymerization reaction, that is the Walker process. Okay, Walker process. So all these compounds are the organometallic compounds, and organometallic compounds is also important for the synthesis of different hydrocarbons, and which is not possible from the to obtain or purify from the petroleum products. I will later on I will say you about the petroleum products. So what is the importance you will realize at that time. So Gilman reagent, Professor Henry Gilman, actually he discovered a reagent that is the R2CuLi. R2CuLi means that is known as Gilman reagent. So R2 means it might be the alkyl, phenyl, benzyl, aryl, and this is the copper metal copper bond, and this is the salt of lithium, that is known as R2. This is the one alkyl group, this is the another alkyl group. To alkyl group we say that is the R2CuLi, that is known as Gilman reagent. And Gilman reagent is synthesized from the Alkyl halide, this is the alkyl halide. When treated with 2 equivalent of lithium, it forms the lithium alkyl, alkylated lithium compound. That is the N-butyl lithium, that is the organometallic compounds. And these 2 equivalent of N-butyl lithium in presence of cuprous bromide, it gives the Gilman reagent. And this Gilman reagent have a versatile uses in the synthesis of different compounds. And with the help of this compound, different compound was synthesized. Though he was not awarded Nobel, but he also did the what I say, that is the milestone, posted a milestone in the development of chemistry. So these are the different methodology of their synthesis. Now the difference between the Gilman reagent and Grignard reagent. So that is very important. Both Gilman reagent and Grignard reagent are organometallic compound. So when cyclohexanone is treated with methyl magnesium bromide and in presence of dilute acid is worked up, that means the hydrolyzed, then it gives corresponding tertiary alcohol. That means the carbonyl carbon that become corresponding alcohol. Okay, but when this one is treated with R2CuLi dialkyl copper lithium and work up, no reaction is followed. So it does not react with the carbonyl carbon because it is hard. Okay, it is very hard, but this is quite soft to attack at this carbonyl carbon. Okay, so this is the difference. But another difference is there. If your compound have a alpha beta unsaturated double bond, and if you treat this one with the R2CuLi, then alkyl group will be attached at the beta carbon. It being as well as reduced, so it is possible. But when alpha beta unsaturated cyclohexanone is treated with Gilman as Grignard reagent, then only it react at the carbonyl carbon. It react only the carbonyl carbon, but carbon carbon double bond that remain unchanged. So this is the difference with the Gilman reagent and Grignard reagent, and this is the synthesis what I told you, and this is the synthesis of your yes, actually this is the alkyl halide. So halogen group that you can replace by the alkyl group, and you will get your desirable alkane. You will get your desirable alkane. So this is the same thing, not necessary to explain again. The same words, same things. Okay, and this is the substitution process. Actually, R2CuLi, and this is the X. Actually, this is a actually just model reaction. A, B, C, and X. These are the different substituents at this carbon, and the halogen is the leaving group. R2CuLi when it is treated, then first what happened? Actually, this X group actually replaced by this by copper. Actually, it is the insertion reaction followed by rearrangement, and ultimately it gives corresponding actually substituted alkane. Okay, and this is the acetyl chloride. The chlorine can be replaced by your, yes, if it is the treated with the Grignard reagent, then you will get called tertiary alcohol. But when acetyl chloride is treated R2CuLi, then you will get the corresponding ketone. Now, different compounds we can synthesize. Actually, this is the 2-bromo 3-methyl butane when treated with the lithium 2 equivalent, followed by addition of the cuprous iodide. You will get such type of substituted alkene R2CuLi, and this R2CuLi that you can attach as per your desirability, and we can synthetic petrol we can synthesize through these methods. Actually, 2,2,4 trimethyl pentane. 2,2,4 trimethyl pentane is known as isooctane, and isooctane we can easily synthesize by means of this Gilman reagent. So these are the different methodology, but their basic thing is there. R2 group is act as a attack at this carbonyl carbon, and it forms corresponding alkoxy group followed by the elimination of the halogen, and it gives corresponding ketone. So this is the same thing. Actually, this is the substituted alkene having the bromine, and this bromine can be replaced by the ethyl group. If you take the R2CuLi, that is diethyl copper lithium in ether medium, then you will get corresponding substituted product. And you see here, this is the iodobenzene. Iodobenzene, this iodine can be replaced by methyl, and you will get toluene. So this versatile different reaction you can conduct by means of this Gilman reagent. So this is the end of this chapter. Next day we will start the another chapter. If you have any question, you may ask me. Hello. And
sir, what is the mechanism difference between Gilman reagent and Grignard's reagent? Is there any difference so that we can identify when it is
yes. That I have explained at the beginning of this topic. You see here, this is the Gilman reagent, a Grignard reagent. This is the Gilman reagent. When you are treating there, it reacts with this one. It gives corresponding tertiary alcohol, but when it reacts with cyclohexanone, it no reaction. At the same time, it is different behavior with the alpha beta unsaturated ketone with Gilman reagent. This is the difference that I have explained. Okay. Hello.
Yes, sir, but how it happens, sir? If another type of question is given, we should know the mechanism now, how it works actually.
How it works?
Both.
I have not explained the mechanism. This is the formation of the Gilman reagent. You see,
sir, you have explained the differences.
Just differences. Yes, actually, this is the synthesis of the Gilman reagent I have discussed. Okay, and the mechanism is this one. You see, this is the mechanism. This one. R2CuLi. This is your substrate where halides are or living group is there. Okay, ABC means you consider it might be the chain compound, a cyclic compound, and any other substituent. So this R2CuLi, it is oxidative addition, means in between carbon and halogen, this total unit, that is the copper inserted. Do you follow me? Copper is inserted. And this inserted reaction actually very unstable, and it rearranged. This R group shifted to this carbon which is attached with the copper, and at the same time copper carbon bond that actually break with the elimination of the halogen. So we will get corresponding substituted alkene. This is the mechanism. This is the fundamental mechanism. He is also discovered from his own lab. Okay, so this is the mechanism. You see here, this is the fundamental mechanism I have just shown here. Without mechanism, why I will say you the reaction. Okay.
Okay, sir.
So any question from other? All you are why silent? Are you paying your attention? Hello.
Sir. Yes, sir.
Okay. So if you don't have any question, then I will leave before that one. Actually, I will post this PPT in this Microsoft team. Okay.
Okay, sir. Thank you, sir.
Okay. So you just wait. Don't leave. Don't leave. Oh, अच्छा ये करते हैं ना. I have to stop the recording. How you enjoy this chapter? Is it okay?
Yes, sir.